Did I do the ding? Ding! Hello there in TV land! We had an amazing set of responses to our colloidal silica video that we just posted with the... Oh, I need that. We posted with the old-timey type footage where we did our slump. So I've got 3 questions. I think I have 3 questions. We're putting them all in the same one in response to. So this is going to be lightning round. But let's see if we can get all of them answered to our best capacity. So Q&A day! Ding! For the first one, we'll progressively get louder as we go through the dings. Ding! From DEYC3, hello David! Thank you for the question. Fantastic! Would the result be the same without high-range water reducer? Is this particle size effect on the concrete caused by the greater number of smaller particles in a given mass of colloidal silica? No! Next question. Just kidding. I got a dirty look from Haley on that. She wasn't happy with that answer. So, David, for the first one, would the result be the same without high-range water reducer? I talk about this a lot. High-range water reducer, specifically a polycarboxylate-style high-range water reducer, I believe is a necessity to using colloidal silica. It helps with dispersion, but more importantly, gets you away from agglomeration. So would the result be the same without the high range? No, it would be worse. And you might not get true dispersion throughout to the degree that we're getting now. I shouldn't say true. You might not be getting as good of a dispersion as you're getting now. And oftentimes you'll see agglomeration, which the particles bounce into each other once they hit the cement. And they end up turning into these big like clusters and monopolizing water, monopolizing colloidal silica, and you're not seeing that same rate of reaction and the same benefit that you would see out of the colloidal silica package that you're using. So, boom! Always use that colloidal silica. And as an exercise for Haley, she's going to put a link down below on one of the videos that we did where we combined colloidal silica with a high-range water reducer. And if we didn't do that video, we're going to do that video. Thanks, David, for an awesome question. Second piece of that, is the particle size effect on the slump caused by the greater number of particles? No. It's the particle size effect, not the number of particles. We're adjusting for that particle size or the particle solid content, but it's more of the active surface area that's giving us that tightening effect. That being said, once we start oversaturating the system with colloidal silica, as long as it's colloidal silica, it's going to cause this effect. So if you get a bigger particle and you put a lot of it in there, you're still going to see this effect. That being said, with a much smaller particle, the 3 to 5 nanometers as opposed to the 45-7, it's going to happen with a lower dosage because it has a higher surface area than when compared to a larger particle with a lower surface area with the same mass replacement or weight replacement. Hopefully answer that question. So who do we got next? Ding! Phil Factory, thanks. Another awesome question. Dr. John, what are these batch sizes equal to? 0.065-ish cubic feet. I think we're doing 2,500 grams of total dry. That's cement and sand. 0.38, no, was it a 0.38? 0.38, 0.47 on the water. So you see, check it out on the video. 0.47, I believe, on the water cementitious ratio. And then the high range water reducer is at 2 mils for the batch. So overall batch size is around 0.065 cubic feet. I thought another video you measure testing in 1 cubic foot batches, ACI 211 I think you said, ASTMC 162 or 39. So when we're doing 1 cubic foot batches, it's ASTMC 192. And when we're doing this, we're using ASTMC 305 and ASTM for the mixing and batching and using the Hobart. And then for the samples, we're using ASTMC 109. David and I did a video on this, the batch sizes and which ASTMs to use, a coffee talk maybe about a week ago. So Haley is going to put the link for that right above. So the link for that right there, that was a little embarrassing. Remember that in this, this video series, we weren't doing concrete, we were doing mortar. That's why we weren't using ASTMC 192 and ASTMC 39. We're using ASTMC 305 and ASTMC 109. If we went to larger aggregates like 3/8 inch and above, then we would switch over the 192 and the C39. So hopefully answer that question. Thanks for that. Moving on to the next one. Okay, so this is from Film Factory again. This isn't the same. This is a different question. So all mixes have the same amount of dry, but what is the rationale for varying the water? Mix 1, 305, mix 2, 340, blah, 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 blah.
Me too.
So the change in mixed water is associated with the milliliters of colloidal silica that we were bringing to the mix and the percent water, and of course we had to take that percent water out of the batch water to keep everything consistent. So, hopefully answer those questions. Thanks for your time. Go concrete! Beat asphalt!